probably not gonna be a super like long math session, but I want to get the actual pie like out of the oven and done and show it on stream too. So we're at least gonna do math for a little bit here. Okay, YouTube stream's up. All right, let's see if we can find a problem here. Oh wait, I'm not showing the. There we go. Okay. Speaking of drinking ASMR. I think it'd be funny just like holding a J and talking about some advanced calculus shit or something. Take a J. That will be really funny. Honestly, I'm not a super habitual like weed user. Like I haven't gotten high in probably at least a year. I do enjoy it. I just don't really. It's not really like a habit of mine, I guess. Last time I bought joints, like I bought some pre-rolls and they did not get me high at all. Like I don't know what I was doing wrong. I wasn't inhaling right, or was just some bad pre-rolls or what. So I've been kind of hesitant to like buy more because like yeah, but I don't know. I don't really like smoking when I'm like in like a shared like, or you know, when there's other people like that I share a wall with and stuff like that. Some weaker shit or different kinds affect people differently. Oh, okay. Yeah, I don't know too much about weed, so I don't really know. Like, it's probably one of those two things. So you're right. Am I allowed to talk about weed on YouTube? I assume I can. Yeah, I know. If I can do it on Twitch, I can do it on YouTube. I'm in a state where it's legal, by the way. Man Covering doesn't know much about weed. Yeah. It's true. And Indiana smokes every day. So position at time t is given by 2t cubed minus 21t squared. Yep. Velocity is that derived. Acceleration is that derived again. Weed not bad for the lungs and health? Depends on who you ask. People will give you different answers. As far as I know, smoking any kind of hot gas is bad for your lungs. Yeah, like Perp says. But yeah, in terms of the health, I don't think there's like a negative health effect the same way like alcohol affects your liver or your heart. Or if it does, it's at least like not nearly as bad. I want to take my word for that though. I'm a random dude on the internet who barely partakes. Use interval notation. Wait, part B. What's part A? Okay. Don, yeah. Don does medical advice. How much time do we have left on the timer? 5 minutes, 40 seconds. Okay. I'm going to turn the sound on. It's going to be kind of a jump scare when it does happen, but I don't want to miss it. Use interval notation to indicate the time intervals when the particles speeding up and slowing down. So that means acceleration is positive or negative. They have an interesting way of doing it, plugging in 0 through 6. Think you're allergic to weed, it gives you skin rashes? Huh. That's crazy. I never heard of that. I wonder if it could be something that's like, I haven't heard of a weed allergy. I mean, I guess I don't know why it wouldn't be possible. But I wonder if it could be like, something that goes with it, like the paper that it's wrapped in, if it's a joint, or like if it's an edible, like something that's like mixed in with it. But again, I'm just a random dude on the internet who knows nothing, so. Gauge how sad it makes you. Some confounding variable, yeah, but who knows? So I'd say speeding up goes to the positive acceleration, slowing down goes to the negative acceleration. So we don't need to care about acceleration here. All Are they using, I think they're using velocity. So I think it's just an interpretation issue here. You would be, you have a 0 in the acceleration at t equals 3.5. Let's not do mental math in my, okay, yeah. I think this is an interpretation issue. If you're speeding up, that means your acceleration 3, 4. Yeah, you must get dinner. Distraction match streamers anyway. All right, no worries, perp. Enjoy your dinner. You have a good one too. Yeah, everyone, the pie is still in the oven. In 3 minutes, I'm gonna go put foil around the edges of the crust to prevent it from over browning, I guess. And then it's gonna bake for another 15 minutes to 20 minutes until the top crust is browned and the filling is bubbly. So we got another like 30-ish minutes before it's done. T minus 42 equal to 0, and solve for t. Ooh, it smells good. Equals 0, so t equals 3.5. You know, from your chart, we know it's negative for t less than 3.5 and positive for t greater than 3.5. Just take your leave for it's late in Europe. All right. Well, thanks so much for hanging out with me. I'll put a picture in the Discord after the stream is over. Yeah. Hope you sleep well. All right, minute 15 seconds. Need help with both parts. Square pyramidal tank with base side length s equals 10 feet and a height y equals 12 feet is filled with water. Okay. The tank is arranged such that the tip is downwards and the base is at the top. Okay. There's a small outlet at the tip of the pyramid through which water is draining into a rectangular box that is placed directly below the outlet. What the heck? I'm gonna have to draw a picture of this. So there's a box below our square pyramid. Oh, I told you that would jump scare me, but okay. Sorry, that sound probably came up on stream too. So I need to go put tinfoil around the edges of the crust. I'll be back in a, I mean, you'll still be able to hear me. To the edge of the crust is brown. I guess let's check the edge of the crust before we go too crazy. Ooh. This thing's coming along nicely. I'm feeling a bit more optimistic about it now. Can I... Okay, it probably isn't a good idea. I'm gonna show it on stream though. Let me walk around with a very hot pie in my hands. 1 second. So I won't be able to really tilt it towards the camera. But here she is so far. It's looking pretty good to me. So I need to put tinfoil around the edges. And then put it back in the oven for another 25 minutes. Sorry, this foil's probably going to sound terrible on stream. I'll put the problem back on the screen in case someone wants to read it, I guess. So sorry, I'm gonna make some tinfoil sounds. Actually, no, I should mute my mic. It's gonna sound terrible. 1 second. Okay. So yeah, the foil's on the crust. Let me set a new timer for 15 minutes. Top crust is brown and the filling is bubbly. Okay. All right, let's keep reading through this problem. Its length 8 feet, a width 6 feet, and sufficient height z to hold all water from the tank and is initially empty. The water exits the square pyramidal tank at a constant rate r of 2 cubic units per minute. Assume that the water level decreases uniformly across the base of the tank, so the surface water always remains square and horizontal. Why wouldn't it? It's a liquid. Let V sub P denote the volume of the pyramid and V sub B denote the volume of the box. Determine the rate at which the water level in the square pyramidal tank is decreasing the water at a certain height. Why? I was about to say gamma. Trying to argue. Oh, okay, that's fair enough, PhD, yeah. Sufficient height z, so they make you work out what z is? Or are we just gonna say, no, we're just gonna let z be a variable and not care about the absolute height of the box? I feel like it's kind of sloppy how it's worded, but I think I know what they're trying to say. Determine the rate at which the water level in the square pyramidal tank is decreasing when water is at a certain height, y. Oh man, they use height y equals 12 and they use y as a variable? Ugh. Alright, I guess I'm not sure how this problem's gonna go. Let's just start drawing. Looks like a fun problem. Put it over there. Okay, so I did set the timer, right? I did. Okay. 5 marker. Hardly knew ye. That's not, I should just draw it like a 2-dimensional projection. It's gonna get messy if I try to draw it 3D. Those are supposed to be connected. So the height is 12, or we're gonna use the variable y for the level of the water. I guess we can separate that. Let's just do the absolute measurements in black. I think we said the, yeah, side is 10, height is 12. Yeah, your eye is shaking. The box has length 8, width 6. So it's gonna, this has to be a little bit 3D. Length 8, width 6. It's like we can call that 8, that 6, and then the height is gonna be z. Hey, Brayden. So derivative relation between two values, like x is one away from y, but not a range of possible values away. A is something to B, B is not something to C, A is something... What? Aim the camera's direction. Say minus is a oh wait, definitive, not derivative. You're doing some... X is one away from Y. It feels like you're doing some kind of like a unique algebra there, Brayden. It's like if A is one away from B and B is not one away from C, I don't think you can make any conclusion about... Maybe you can say A is... No, I don't think you make any conclusion about A and C. I think you would need more information. Because you could construct valid cases, I think, where either of those are true. I think. So wait, actually, well, what's the goal with this? Related, or not related rates, but... Is it related? I guess it is related rates. Determine the rate at which water and... Wait, 2 cubic units per unit. 2 cubic units per minute. Two. Wait. Okay, yeah. V sub P be pyramid, V sub B volume of box. Okay, so I guess V sub B is 8 times 6 times Z. V sub P, I need to know the volume of a square pyramid, which I forget. 1/3 a squared h. So 1/3 times 10 squared times y. Technically the entire thing is 12, but y is going to vary as it drains. Okay. Now actually you can know that, for example, if m is one away from b, then c is one away from b. It's not. Okay, fair enough, Brayden. I'm just like, it's been a day for me, so. It's hard for me to like think through the logic like that without like writing it out. The rate at which the water level in the square pyramidal tank is decreasing. So we want to take d by dt. Okay, Brayden. So I think we want to derive this through in terms of time. And we know we're losing 2 cubic units of water per minute. So dy dt is minus 1/50? No, 3/50. That seems kind of slow, right, for the level of the tank? Should 10 not be a constant? 10 shouldn't be a constant. It needs to be related to y. I think. That's, yeah. Z are like 8 and 6 are fine to be constants because it's a square, or not, you know. Because it's a rectangle or whatever it's called, but we have a curve here, so, or not a curve, but a slanted line. Generating is a bit hazy too. Constructing a small graph to try and picture it. Okay. So we can figure out the equation of a line here. So we can take that as our origin. Then we have another point, 10, 12. Connect them. We figure out the equation of this line, and that's how we relate the height of the water anytime to the width across the tank. So that should be y equals rise over run. 12/10 simplifies to 6/5. X. I'll say S, I guess. So when S equals 10, we get 12 back out. It's our sanity check. Yeah, okay. So then now when we come down here, we can use this relationship here. We want to actually get S in terms of Y. So we want everything to be with Y. The rate at which the water level in the square pyramid tank is decreasing when the water at a certain height is at a certain height, y. So yeah, we y. Okay, so we're going to want to figure out, we're still going to derive this, so by time it'll be a function of y now, which makes more sense to me. So 5 squared is 25, 6 squared is 36. 36 times 3, 108? Because 90 plus 18? Yeah. Okay. Now we want to take d by dt. Three and 1/8, they should have a cancellation. 3, isn't it 36? Yeah. And we know that dv dt is a constant rate of -2, I guess? So dy dt is, divide those over. It's always negative, which makes sense. This seems reasonable, I think. As y gets bigger, the rate which it goes down becomes smaller. Does that make sense? If you're losing... Yes. Because the higher up the water is at the tank, the more width you have. So there's just like more water in each like layer of the tank. So the level will be going down slower the higher up in the tank you are. I think that makes sense. What's left on our timer? Ooh, 50 seconds. So I think that's our answer for part A, right? Yeah. For part B, we want the same thing, but with the rectangular box in terms of z. So we want it in terms of v, which the rate at which the height of the water is z, and the rectangular is changing when it's collected a certain volume of water from the tank. So I'm not gonna. Oh, frick! Sorry, jump scare. Yeah, B seems like it's gonna be a constant, right? Let me go check the pie. It's potentially done. If the top crust is brown and the filling is bubbly. I think it'd stand another few minutes in the oven. It's not bubbly. It's like getting to be brown, but not quite brown. I'm gonna set another timer for 4 minutes, let's say. So the pie has to look alive. And it didn't seem alive, I guess. It does. Oh man, the crust smells good. I can smell that right now. So the rate at which the height of the water is z and the rectangular box is changing when it's collected a certain volume of water from the tank. So like the one is collected a certain volume of water from the tank is what's confusing me. We could definitely take d by dt of each side. But we know it should be like, this is a constant rate of 2. So it makes sense that dz/dt is filling up at a constant rate, or dz/dt is just like a constant. 1/24. But it's only they wanted that in terms of the volume, like, or what's the... Creature one baked, I didn't start bubbling such moves if it was some creature. I mean, I guess if you're imagining like bugs, then yeah. But, you know, it's just boiling. So I think maybe they're baiting you because this doesn't depend on the volume. The rate does not depend on the volume. And I don't see how it possibly could. Hey, Trixie, how's it going? So I feel like we know enough to maybe write an answer to this person. I think for part B, they're kind of tricking you. That's my interpretation of it, at least. Yeah, I'm good too. Thanks for asking. Oh, and they deleted it. Okay. Well, I guess we had some fun with that question. Hey, Montrealian? How's it going? Welcome in. It's a funny name. Okay, I do have a pie in the oven right now because of Pie Day. I'm making my first pie ever. It's totally going to come out in 1 minute, and there's going to be, the timer is going to go off, and I think it's going to be heard on stream, which I'm sorry for the jump scare, but I want to make sure I don't miss it. Well, that's sorry, that... Did I miss something with this particle movement one? Speeding up and slowing down. It's speeding up. Like, isn't it, if the acceleration is positive, is it not speeding up? Is there something more to this that I'm missing? I feel like that should be simple. Either way, the person's being a little bit like rude about it. Oh shoot, I have to go check on the pie. 1 second. If anyone has something to point out about like this problem about when it's speeding and slowing down, please tell me, because I feel like apparently I'm missing something about it. I can definitely hear it bubbling. I think I'm gonna pull it. Yeah, it's not... I guess the crust I saw wrapped in tinfoil, but that's how it looks like. You can really hear it bubbling away, so I think we're gonna pull it here. And let it cool. For a lot of simple calc stuff like this, yeah, I mean, I feel bad for this person, but they also, you know, they didn't have to be a dick about it. Oh wait, I didn't... Oh my god, I forgot to take down the browser before I showed the pie. Sorry about that. I'm coming back. I'm gonna take the tinfoil off too, so we can really see it. All right, this is the pie. No, I'm not forgetting to take away the browser. So yeah, it stopped bubbling now, but I think I'm gonna call this baby done and let it go and cool down. I guess I'll get it up on a rack. I don't know if that really matters, but do it. Ah, unhand me, foil. Thank you. Just give me like 1 minute and then I'll get back to the computer. Okay. Okay. T is measured in feet when it was just used at time? I didn't see that part. Okay. What? I'm not going to reply to this person because they're being a dick, but I do want to know what the... Yeah. So if it does relate to the sign of the velocity. Maybe I will reply to this person. I'm gonna like let them know. I don't know. Okay, yeah. So I mean, I can visualize it now. If your velocity is positive and acceleration is negative, it does mean that you're slowing down. Get the music going again. Do I take the high road? I'm having a hard time taking the high road here. For someone who apparently already knows the right answer, they sure got it wrong a lot. That's what I want to say. I'll take the high road, as much as I don't want to. It's like I was wrong. I'm sorry that person is frustrated. They're probably stressed about their grade, but your homework is your responsibility. Man, but I don't really want to let my incorrect information be there. Because I did write bad information here. So I shouldn't let that stand. Because the person is right. I was wrong. I don't worry, posterity. Ask him, can you please tell me what is wrong with what I said? I mean, the person I am legitimately wrong, Trixie. That's why I'm bothering to do anything at all here. So otherwise I would just ignore this, but the person, like, I shouldn't let the incorrect thing that I said stand. Has been sticking out as was pointed out below. Unfortunately, I'm going to be passive aggressive here. How about that? That's going to be my happy compromise. I'm going to take like the medium road, which is passive aggression. I don't know if that's really the medium road at all, but we can at least. I'm not allowed to have an off day. I'm not allowed to have an off day, and sometimes be incorrect. So I feel I should point out, or I feel I should clarify that what I said above isn't entirely, or isn't clarify that sign of velocity is relevant here as well. Unfortunately, actually no, it's even more passive aggressive. I've been informed I'm not allowed to have an off day and something's being correct. It's Pi Day, yeah. All right. We'll post that. So, you know, we're taking, you know, I'll be extra passive aggressive. I'm going to take away my upvote too. I got ops now? Or PP math Reddit OPs? What do you mean by that? Go to your personal training session? Awesome, Trixie. I'm not sure how much longer I'm going to go, but I'll be here for a little bit. But yeah, thanks for hanging out so far. Shorthand for opponents. Oh, I haven't heard that. Yeah, no, I do that. Yeah, that person's my like rival now. Puzzle limits of fx and gfx both exist, and c and k are both real numbers. Determine the limit of following functions when the limit of following function does not exist. So my final exam done. Yeah, I'm about to say it's one that's kind of interesting. Because you have to consider fractional exponents and negative exponents for the ice number 4. But you know what? Yeah, let's try and write this out. I see it does have someone with an answer there. But let's, before we look at that, let's try it for ourselves, because it sounds like it's gonna be it's relevant to the real analysis. Okay, we'll go with that. Really, marker? Okay. Okay. So let's do green. So let's consider, was it number 4 they called it? Yeah. I don't know why. I mean, I'm not going to write down 4. So f of x minus g of x to the k. So if f of x and g of x both individually have limits, I assume for all c. That's maybe not the clearest way to phrase it, but I think that's what we're going to say. Oh shoot, it's being blocked by the problem. Let me shift this over a bit. We need to do a horizontal translation. Okay. So k and c are any real number. So if k is a non-negative integer, I think we're just in business. Because you could always expand out this and distribute the limits to each thing individually. So let's for k belongs to z plus union 0, I guess is how we'll say it. Limit as x approaches c, I'm going to just do some shorthand here, exists for all c belongs to r. I think you can say that off the bat. Ah! Sorry, I just made something drop. So I guess naturally let's consider negative integers next. For k belongs to z. Oh, that's not the right z. Z minus. The limit, it only doesn't exist if they're equal to each other. I'm trying to think if that's true for like every power or just -1. It should be true. It should be the exact same for every power though. If f of c is not equal to g of c, I think is how I'd say that. Or maybe the limit. Ooh, should we say the actual function? The function doesn't have to be defined at c, does it? So we should say the limit. Oh, who's that? Critical thinking. Thanks for the follow. Could use some of that. So yeah, I think we want to say the limits aren't equal, right? They don't have to be defined. Yes, because you have like a removal discontinuity. I think I like that. That's what I was getting to next, Zach. How do you integrate that rational function? Ooh. I wonder if there's a trick there, critical thinking. I'm trying to figure it out. Let me just kind of like wrap up this problem. If you don't mind, I don't think this problem has many more steps to it, so I'm just gonna wrap it up and then I'll think more about your integral. There's definitely a long way to do it. I'm trying to figure out if there's a short way to do it though. So if k how do you do it like that? If k is rational, we need f of x to be greater than g of x. Well, if it's an even rational, if it's odd, we're fine. Or if the denominator, rather. Where k equals a over b. If b is even, then we need f of x to be greater than g of x. If b is odd, I think we're fine. Well, we have to worry about the signs as well. For for k greater than 0 and even b, as x approaches c exists for f. We want to do the limit again, don't we? Greater than limit. This will be safer to do. So we want to ensure we have a positive number in the basically potential square root. You're going to wait? All right. Thank you so much for understanding critical thinking. If k is negative and even b, actually this works because we're already assuring they're not equal to each other. They could be equal to each other. Oh, yeah, they're allowed to be equal to each other. So we do need to split it up for negative k. For k less than 0 and even b, as x approaches c exists. And I think we just use strict inequality here. I'm not actually like proving it, I guess, but this makes sense to me, at least. So this assures they're not equal to each other either. Same way we had to assure they're not equal to each other up there. Which actually, this logic applies up here too. We might not have had to consider the integer cases separately. So if we have an odd k, I think we have options. Or for odd b, I'm sorry. For odd b, we don't need to worry about a negative and a square root, because like the cube root of -8 is -2. That's fine. There's no issue with that, as far as I know. For k, it's like positive k and odd b. It always exists, is what I'm saying, right? I think we're good. No. What is the cube? The cube root. It's defined over all x. Yeah. So the limit is going to exist for all c belongs to r, I think. And then for negative k, we just need to ensure they're not equal. That's my guess here. I haven't done it for number 5, but I should look at critical thinking's one first. Okay, so critical thinking. You want to solve the integral x squared minus 3x plus 7 over x squared minus 4x plus 6 squared. So that's a... Neither of those are factorable. Shouldn't limit f of x be greater than the limit of g of x for k is negative? For an odd to be, I think you're okay. Because you don't mind having a negative like cube root. Was my logic there? It's like I'm not crazy, right? Like if you graph cube root of x, it's defined for all x, right? I think you only need to worry about a positive under the root if it's an even. Denominator. Y equals CBRT x. Yeah. It's like you're allowed to have a negative cube root over here. So that's why I split it up based on the denominator. If your rational number is like, 2, 4, 6, 8, then you definitely need to have it greater than. So critical thing for your question, I think I'm gonna... Yeah, no worries, PhD. I think I'm gonna start putting this into Wolfram and see if we get something clean, which implies there's a trick here that I'm missing. Or if we get something very ugly, which implies we have to do this the hard way, which I hope we don't have to. But I don't want to waste time assuming I have to do it like the hard way or something like that. This looks like the result of a partial fraction, doesn't it? Ooh. No. They complete the square. Really? Let's try doing Wolfram's technique here and seeing what happens. So they complete the square and then you take u equals x minus 2? I don't know where they're going to go with that, but I'm going to erase this on the board because I need the room. But I think I'm comfortable with what I've written here. I can't think of anything that's wrong with it, at least. If k is irrational... Oh, I should have considered irrational k, I guess. Yeah, what do you do with irrational k? Like, can you have -3 to the power of 1 over pi? Is that valid? I don't even know. So, okay, I guess I'm not completely happy with what I wrote, but for the normal cases, I'm happy. Irrational is kind of weird. Where's the pi guy? All right, I'll show you the pi central. Sorry, just one more second. Critical thinking. I baked a pie today, and I want to show off. There it is. I think it looks pretty good to me, at least. I can't cut into it yet, Jed. It's too hot. I'll have to cool it on the windowsill. Well, no, then some like hobo is gonna like smell it and like float over to it, like in those cartoons. Heading in rational k in decimal form, or interpret a rational k in decimal form. That's a good question, Peach Tea, I guess. Fraction form makes sense. Yeah, I'm not sure exactly how it'll work, Peach Tea, but I guess let's try and get this integral done first. So x squared minus 3x plus 7. X squared minus 4x plus 6 in parentheses squared. Okay. So if we're blindly copying Wolfram Alpha, we're going to complete the square and the denominator. So minus b over 2a, right? It's going to be, we want plus 4 to be here, so we also need to do minus 4. So that way we want x minus 2 squared here. So that factors to x minus 2 squared plus 2, because minus 4 plus 6 dx. So now Wolfram Alpha took u equals x minus 2, which seems reasonable. And I think we're going to have to remember that that means x equals u plus 2 and put that up in the numerator. That's where I think they're going with that. It also means du equals dx. Let's apply the sub. Yeah, I don't see what else we're going to do, at least. You see a gray hair? Yeah, probably right. Continue fraction decomposition. Oh yeah, you definitely can. Maybe Peach Tea, yeah. Be interesting to investigate more. So x equals u plus 2 squared minus 3u plus 2 over u squared plus 2 squared du. Oh, no, just u. So oh, dude, Wolfram Alpha is smart. We split this up into 3 fractions now. So the numerator can be split up into 3 separate fractions. So u plus 2 squared over u plus 2 squared, that's an easy integral. So you just get 1. Oops, minus. Over here, we're going to get a cancellation for the next one. 3u plus 2 over u plus 2 squared plus 7 over... This one will be a little bit harder. U plus 2 squared, but it's possible. It's going to be in arctan. We're going to have to factor out and complete the square again, or unsub? I'm not sure which. I don't know, guys. It's going to be some form of arctan. I'm just not sure exactly how it's going to go yet. Either way, that one just going to integrate to u. This one is going to be the u plus 2 and the u plus 2 will cancel, so it's 3 over u plus 2, which will be ln. U plus 2. That one, I'm still debating. So should we have... I was just about to wonder if we should have never subbed. Wait, did I do the sub right? Oh no, it is squared. Oh no. No, 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 no. I made it. I made it too easy on myself. Shoot. Yeah, it's x minus 2 squared and then squared outside. Never mind. Wishful thinking. So what do you do? To use fraction decomposition, how you solve the problem? Oh, we have to do that? Oh, it's gonna be painful. Tim you have to do an integral. So do you have to do this with partial fractions? Yeah, we can do that. I need to look up what we do with repeated roots. You do have to do partial. Oh gosh. Okay. Your teacher doesn't like you then. This is a little bit more of a unique situation for partial fractions. I need to remind myself what you do when you have a repeated irreducible quadratic. I want to use pulse nodes, but it's not working. Ugh. They don't even cover this? Oh, you just do separate. I assume you can do the same thing, like b1x plus c1 plus b2x plus c2. I don't mind looking at Wikipedia. The reason you dropped out of college? Yeah, Cosmolano. This is a weird improper fraction as well. Or, it's not improper. The degree on the bottom is greater than the degree on the top. We have a repeated irreducible quadratic, which is weird. A very simple question. When is minus 1/4 negative 2 equal to negative 16? I think it's the minus sign being in front of the bracket bio, yeah. If the minus sign is on the inside, then it becomes positive. There's some weird rules sometimes with things like that, though, so I think that's right, at least. If you want the entire thing to be negative, the negative should be before the bracket. If it's inside the bracket, then the negative sign doesn't matter, I think. Go away. Oh, well, in that case, yeah, It's positive then, because the negative sign is on the inside. You know, just I'm feeling crazy. And like I'm gonna say the wrong thing. Just do a little sanity check. Yep, positive 16. Dude, critical thinking, this is a very funny situation. Like, I didn't realize it. I don't think I've encountered repeated irreducible quadratic before. Let me give Wolfram Alpha just the inside and see what it spits out. All right. I think I know what to do. I just haven't done it before, so we know what the answer should be. Let's see if we can get that right answer. Oh, I know what the trick is. Okay. -2 to the -2 is positive 1/4. If you're be careful about how you write it. -2 to the -2 is positive 4, but -2 to the -2 is negative 4. That's like the difference there. So it's a little bit ambiguous the way that you wrote it, but that's how it works. Oh, sorry, 1/4. Flip the fraction. Not 4, but like 1/4. Yeah, critical thing. If you don't mind giving me the answers, I think Wolfram Alpha did it right too, but it's always helpful just to have a point of reference to make sure that I'm not going too far off the rails here. All right, so partial fractions. Squared minus 3x plus 7 over x squared minus 4x squared. It's equal to, so with a repeated term, you need one term for each degree. Like in degree first, like that's putting the outside. When I say degree, or I should say exponent. I'm gonna make the first one for degree 1, which is just a quadratic. So I'm gonna say ax plus b over x squared minus 4x plus 6 plus, and now we're gonna have a quartic on the bottom, so we need terms up to cubed. So it's gonna get a little crazy. So it's gonna mean there's gonna be a lot of algebra. It's just ambiguously written by you. You can't really. Arc sine. Really? Is this a trig sub? Usually, you don't really get arc sine from partial fractions. Like, there's an arctan, sure, but that looks very simple. So I don't think we're using partial fractions. Oh, that's the wrong answer? Okay. Okay, thank you. No worries. So I'm willing to go through this partial fractions decomposition, I guess, but this is going to be a lot. Bio, I didn't say anything else about your problem, just that you can't be certain which one it means if it's just -2 to the -2. 7/8 √2 inverse tangent x minus 2 over √2 plus 3 x minus 8. Okay, so that agrees with Wolfram. Okay. -2 to the -2. Well, so, that wording implies that the -n is on the inside. So I'd say it's +4. So as long as it's being consistent, like Peach Tea said, you can take it as +4. Actually, oh no, it's not being consistent. Or rather, it's being consistent the other direction, potentially. You just don't know, Bio. That's the... I'm sorry, there's not a better answer, but you just don't know. Like, that's why it's bad to give numbers like that, because the reader doesn't know. See, I think we have to do this partial fraction decomposition critical thinking, and it's going to be a little painful. Oh my, actually, oh no. It's going to be very painful. No? Okay, no. It won't be that painful. Okay, so we have to multiply everything through by the denominator. X squared minus 4x plus 6 squared. So thankfully, we get some cancellations. That cancels with that, and that cancels with that. So we don't have to do any multiplication on the middle term there. We get x squared minus 3x plus 7 equals ax plus b. I keep writing b wrong. Then 1 power of that, because there's a partial cancellation. And then this one entirely cancels. Okay, so now we need to multiply this out, which could be worse. We got off easy, I feel. So ax cubed minus 4ax squared plus 6ax plus bx squared minus 4bx plus 6b. So we multiply all those out with each other. Plus, and then just this repeated, cx cubed dx squared plus ex plus f. Now we're going to equate coefficients. So we have cubes over here. We don't have a cube over there. We do have an invisible plus 0x cubed though. So looking at our cube terms first, we have 0 equals, we have an a here. Looking, we have a c there. So a plus c is 0. Let's look at the squares. So we have a 1 for the coefficient here, a minus 4a here, plus b there, plus d there. Ooh. And that's it. Let's look at just the x. We have a -3, a 6a, minus 4b, plus e. And then the constant is 7, 6b, and then an f. We don't have enough equations here, do we? Did I set it up wrong? Do we only have ex plus f over there? Is that what I did wrong? Or I guess cx plus d? This is where I'm... So we have 4 equations and like 6 unknowns or 5. So I think we actually are, maybe I didn't need the x cubed and x squared terms. I thought we would. So that's where I'm kind of having to explore the problem, I guess, alongside you. we should get something that's possible to solve. So let's try cx plus d. And Wolfram says the partial fractions, we don't have a, yeah, okay. We don't end up with like a cubed or a squared in the partial fraction decomposition that Wolfram Alpha gave, so I assume that I just made an error in that setup. There we go. So now let's re-examine this. So we still do have a cubed, so we have 0 equals a, and no other cubes now, so a is just 0. Then we have 1 for x squared. We have a minus 4a. We have a plus b, and that's it. We have a negative 3 for x. We have 6a minus 4b plus c. Then we have a 7 for the constant. So we have a 6b and a d. Okay. We already know a is 0, so let's work out that b is 1. Because if a is 0, then just b equals 1. Now we can come down to this next equation. A is 0, b is 1. So negative 3 equals negative 4 plus c. C also equals 1? Funny. Oh, and look what we get down here. If b equals 1, then 7 equals 6 plus d, which means d equals 1. Just a whole bunch of 1s. And I think it matches what Wolfram Alpha did. Yeah. I don't think that I did something wrong if I got this, but it does match Wolfram Alpha. So our partial fractions come out to be a is 0, b is 1. So it's just 1 over x squared minus 4x plus 6 plus c is 1, d is 1. Just x. Okay. That you can complete the square and get an arctan with, which we'll do. This is still painful, isn't it? Oh, no. Penn Center taught me a trick here. To do something like this, right? Or maybe the square wasn't there when Penn Center taught me. I think we can make... I don't need to remember, but I think there will be a trick for that second one. So let's do equals. I completely square there. Well, how should we do this? Let's split up into two. Okay, no, I will come over here, split up into two different integrals, because we're going to need to do two completely different techniques to do each of these. Okay. So this first one we complete the square with. And we already did the completing the square earlier on. We said it was x minus 2 squared plus 2 is what we got. We complete the square there. Those two things are exactly the same. Now this, we want to do a u sub, but we need to do a clever u sub, I think. Well, we never want to do a u sub that's not clever, I guess, but how's this gonna work? So if we want to, I think we want to take u equals x squared minus 4x plus 6, which means du is going to be 2x minus 4 dx. And we want to find a way to make that 2x minus 4 match that x plus 1, I think is the idea. Hey, Linux physics. Okay, yeah. So We're gonna need to mess with the numerator here somehow, somehow. But this is what we want to do. The sign being not the same kind of scares me though. So this is what we get after we do the U sub. Oh, du. But we need to mess with the numerator and I guess try to make it force it to match the denominator in some way. So we can do some like plus x minus x type stuff is where I'm trying to go with this. This one over here we can do a U sub 4 and we'll get arctan. I'll call it V just to make things distinct. So this integral, we could say x is equal to like 3x minus, no, 3x minus 2x. In that, you know, ooh, it'll be easier to look at if we factor the 2 out, right? So I take the 2 out and it's just x minus 2. That's a little bit easier to work with. So we can say 1 is equal to negative 2 plus 3. Well then, what happens with that plus 3? Is this right? Because we're not doing with, like, we still get something with a 3. Why is that minus 6, Linux physics? I don't get where that minus 6 comes from. Oh wait, are you saying 2, you're saying negative 4 is equal to positive 2 minus 6? Um... I don't see how that fixes the problem though, Linux physics. I'm getting stuck here. I just think I'm not being good at the technique right now. Hmm. I'm gonna maybe give this problem to Wolfram? I don't know. I should be able to do this. I'm just getting a little bit tripped up on this part here. Hey, Stooky. Yeah, I'm gonna give this that integral on the right to Wolfram. You did, but I can go and get it quick. It's just cooling down right now. So there she is. Got a little pie in it and everything. Still pretty hot, to be honest. I guess I probably won't be able to cut into it until tonight. Thank you, thank you. And right now I'm working on this pretty difficult partial fractions integral from critical thinking. You know, a little bit stuck on the last part here. We've done the partial fractions, but if we have x plus 1 over x squared minus 4x plus 6, also squared, how would we go about doing this? Oh, you consider the 3 separately, of course. Oh my gosh, there we go. That's a part of the technique that I forgot. You don't include that 3 in the sub. Okay. How should I explain this in a more clear way? So, okay, this is gonna be a pretty stupid way to write it, but I'm just gonna keep the work that I have going here. So all I've done here is say that 1 is equal to -2 plus 3. So I get this cancellation of the x minus 2's here. But we still have the plus 3 to contend with, and that's what I was struggling with this entire time. But I figured out how. We're gonna have to split off the plus 3 and not do the sub, and I was thinking if I should just write that in a different integral in the first place, but I'm just gonna continue it from here, because I think anyway I read it's gonna be weird. Normally when I have an integral like that, I just have the integral memorized that it's for arctan, so it's gonna be 1 over root 2 arctan v over root 2. This is going to become 1 over 2u squared du from these two canceling, x minus 2 over x minus 2, plus 3 over 2, and now instead of shoot, no, this is really stupid. This is a little bit too stupid for me. I'm gonna say 2 du plus 3 over x squared minus 4x plus 6 squared dx. So I only want the sub to apply to that one, I guess. So yeah, this is a hard problem. Sorry I'm not doing it smoother, but yeah. Now do we have to complete the square with that? I would think so. Is there a better way we can do it? Numerical methods can make this easier, just not exact. I mean, yeah, a numerical method would be easier, but you definitely wouldn't be able to do that in a calculus class. do you integrate that? And to consult with Wolfram Alpha again. So yeah, they're saying to complete the square also. And then do a U sub. And then what do you do after that? Like, I could get that far in my head, but you have a quartic on the bottom? Oh, do you do a trig sub? I think you do a trig sub. Jeez. This problem was a journey. Alright, so we're going to complete the square on that one. It's 2 squared plus 2 squared dx. And we already have it worked out. We're going to do another sub. Should I make it a W sub, I guess? Three over W squared plus 2 squared dW. Okay. I'm also out of room, isn't that great? Let's come up here. So I'm gonna, like, this part is integrated, so I think I'm just gonna drop it off. We'll integrate, I mean, I'll write a little, like, a quote mark there just to remind me that there's something there. But I'm kind of running out of room here, so I need to make some practical decisions, including erasing my little for fun drawing. Actually, I guess if I erase that, we do have enough room. And that integrates to minus a half. Minus 1 over 2u. And that's not v, that's not x, that's v. We need to unsub. This, I think we're going to take w equals, oh no, it's plus 2. How the frick do you do that? I thought if you do w equals sine, you can use Pythagorean identity. But not one that's a plus 2. Okay, back to Wolfram. Oops. Oh, you do a trig sub with tangent. God, that's ugly. Okay, so we're taking x equals root 2 tangent. I need a new letter. We're gonna do a theta sub. It's gonna be a lot of layers to unsub through. Let's do a theta sub. W equals root 2 tan theta. So dw is root 2 secant squared theta d theta. So we get plus the integral of secant is 1 over cosine. Well, we don't actually need that here, do we? Actually, well, if gets the cosine on top, how does that work? Oh my god, the siren. Actually, my mic didn't seem to pick it up that much, thankfully. The fire truck that just drove by. Dude, I'm sorry, I have to use the bathroom so bad right now. I'm gonna put up my BRB screen because I have to pee. Sorry about this. Okay. And that's funny, Peach Cheese. Like, you mean they're in the science and technology category? Or like the software and game development? Okay, so DW is that. Oh, I see how we get the cosine. I was getting too far ahead of myself. W is root 2 tan theta. This root 2 was chosen, okay. Because it's W squared, so that root 2 is going to get squared. The tangent is going to get squared. So it's going to be 2 tan squared theta plus 2 squared d theta. Okay. Let's unsub the v, which is x minus 2. Unsub the u, which is that quadratic, x squared minus 4x plus 6. And now here, we factor the 2 out. And then there's a Pythagorean identity that tangent squared plus 1 is secant squared. So when you factor the 2 out, it gets squared on the way out. So we have root 2 secant squared theta over 4. Tangent squared plus 1 is secant squared. So secant squared squared is secant to the 4th. Now we get a cancellation. Actually, these are unsubs, so I don't want to rewrite them constantly. Just gonna do little quote marks to say that these are they haven't changed. Because we only really care about this one now. Comes root 2 over 4. 1 over secant squared is the same as cosine squared. Okay. Now we have to do the half angle and cosine squared, and we're almost done. Oh, just chit-chatting category now? Okay. Let me find my cosine half angle, double angle. So cosine squared is 1 plus cosine 2 theta over 2. Okay. 1/2 plus 1/2 cosine 2 theta d theta. Okay. This we can integrate root 2 over 8 theta plus multiplying the root 2 over 4 back in. Root 2 over 8. Cosine integrates to positive sign. And we have to do, I'm going to do a mental u sub on that 2 theta. So it's a window that we have to divide by 2. Okay. Now we have like 50 subs to go back and undo, but we can do it. Or, you know, to get from theta back to x is what I'm talking about. So theta, oh god. Theta is arctan w over root 2. Okay? That's ugly. Hate it. But how do we deal with sine of 2 arctan? How do we deal with that too? We can use the sine 2 theta. Okay, we need to do an identity on that, I think. So I can't figure out how you need to draw a right triangle here, and I can't figure it out. But we do know that sine of 2 theta is equal to 2 sine theta cosine theta. Root 2 over 8, because I'm multiplying by 2. Sine theta cosine theta. Then this, I'll know how to simplify once we get an arctan. This one's ready to be unsubbed directly. W is x minus 2. W equals x minus 2. This one, I'm not quite ready. What does that sound? Oh, it's just the song. Okay. Yeah, Peachy. I think we had the same thought at the same time. So yeah, arctan W over root 2. Cosine arctan, we can use the same right triangle here over root 2. Okay, so when you simplify sine of arctan of something or cosine of arctan of something, or you kind of need to draw a right triangle. So tangent is opposite over adjacent. Sorry, yeah, opposite over adjacent. So W root 2. Pythagorean theorem by hypotenuse is root W squared plus 2. So then the sine of this right triangle is W over root W squared plus 2. Cosine is root 2 over that. Okay, almost done. Now we can take it from W back to X. What do we even have from before? So, like, we have an arctan and an arctan with the same argument. I think we're going to get the same quadratic as well. I'm going to not write the quotes anymore and write out the entire thing. Actually, I'm just going to combine it. I'm going to combine this and that. So that's root 2 over 2. So multiplied by 4 root 2 plus root 2 is 5 root 2 over 8 arctan x minus 2 over root 2. Plus, or minus that. So we should get some combining terms based off what the final answer was. Okay, here, root 2 over 8. Root 2 times root 2 is just 2. 2 over 8 is 1/4. I'm going to unsub the w as well. So w is x minus 2 over 4. X minus 2 squared plus 2. That's the completing the square. Yeah. So we get the original irreducible quadratic back. Plus c, don't forget plus c. So we just combine those two like terms, and I think we're done. I think we're gonna get x minus 4 on top. Let's see if I did it right, or if I made it in algebra error somewhere. Plus, so that's multiply it by 2 over 2. There's a minus sign in front. So yeah, it's gonna be x minus 4. And I think you maybe had it factored out a bit differently than I did. So let's see if that's equivalent to what you wrote. Does integral look zeta sexy? I don't know. Hey, Pen. PFD topics? PFD? Oh yeah, Penn Center for a solution exists. I'm out of here. Yeah, Linux physics. Penn Center. When I had to integrate x plus 1 over x squared minus 4x plus 6 squared, I had to do the thing that you taught me a different time I streamed had a similar one. We had to like rewrite the numerator a bit for convenient cancellation. Partial fraction comp. Oh yeah. So I had to use Wolfram Alpha a bunch, but so wait, so what did critical thinking say the answer was? 7 over 8 root 2. No! I got 5 over 8. Is it a simple mistake that I made? I don't see what the mistake I made was immediately. Arctane x minus 2 over root 2, did that right. 3x minus 8 over 4. Oh no, I messed up the numerators of each. So I'm really close. But that should be a 7. That should be 3x minus 8. And otherwise I match. So at some point there should be a... That's supposed to get multiplied by 3? I'm searching. I don't see what I did wrong. I don't know. Some error tests and see if we can call it a day. Yeah, I'm about to say that, like, I don't know what I did wrong exactly. I did some small thing wrong here, but it's gonna be really hard to spot it. So, okay, critical thing, what I can tell you is that the technique I did is right. I just made some little algebra or arithmetic mistake error somewhere, but the approach is at least right. The partial fraction decomposition is right. Okay, I'm glad, because I explained it horribly because I didn't know where the problem was going. So I'm sorry I can't give you the exact right work here, but hopefully now that you know, like, kind of what technique to do, you're able to get the right work. So my next step here will be like plugging each line into Wolfram Alpha and seeing where it stops being equal to each other, and that's going to be a lot of work, and I'm not sure I want to do that. Yeah. Let me know if you had any question about like what I did, I guess. Because otherwise I think I'm going to move on. Thank you so much. No problem. Well, I was glad I was able to help you out a bit there. Yeah, it's not an easy integral at all, though. Let me go get some water because I'm all out and I'm getting kind of thirsty. Be right back. Actually, I'm not going to be here rescreen. I'll just let you guys hear me. Oh, you know what? We should look into the irrational powers. That Peach and I were talking about before. Oh, sorry. Near the same thing, but a 5 instead of a 7 at the beginning, and x minus 4 for the numerator of the, yeah. I don't think they're going to be equal. I don't think there's any identities here. That'll make it just like a vertical translation. But you can still try, I appreciate it. Just a bit off? Okay. Yeah, I could start all day. Honestly, I'd almost rather do it from scratch again, or I do it from the partial fractions again, because I don't know where I made the error. If I was going to try to get the exact right answer, but I don't think I'm going to do that because it's on the critical thing. Got what they needed. So before that, we were working on this kind of interesting limit problem. What's up, Linux physics? And we kind of had the question of what happens if you have an irrational power, which I really don't know what the rules are for an irrational power. You have, say, -2 to the power of pi. Is that valid? It is. Oh no, it's imaginary. So for IC's purposes, we're saying it's not valid. How do you justify that? I don't know how you justify that, I'm gonna be honest. That makes no sense. No answer makes sense to me. What's this PhD? Oh, is this the 2 answers? Yeah, they're just yeah. If one was like it's possible to have two different looking answers that are both correct if they're just a vertical translation, but this definitely isn't. Just a bit flatter. Yeah, that makes sense. Thank you for trying with that though. So what's 2 to the negative pi? That's valid. About 2 to the 1 over pi. I mean, that's just another rational number, isn't it? So it seems like you can't have irrational powers of negative numbers. I couldn't tell you why. But I guess for this one, if k is irrational, you just have to have the same stipulation that the limit of f of x as x goes to c is greater than the limit of g of x as x goes to c. If my, terrible proof is right. So I guess, yeah. Heron's method to calculate square root. Guess 3. Next guess. 3 plus 10 over 3. Oh, really? So you always do the last guess plus 10 over the last guess. And that's an approximation? Or, if you do it infinitely, it's exactly. That's cool. Can you discover this method in ancient Egypt? You can discover the method using Newton's method. Oh, it does look like Newton's method, doesn't it? Um, that's like a neat little like fact, I guess. I don't know if I'm gonna go like try and go down actually using like Newton's method as a and applying it to become like Karen's method. Like I kind of want to work on 5 for this one, but that's like an interesting thing to know. You do 10 minus x squared solving f of x equals 0. Oh, okay, that makes sense. Okay, so I'm gonna erase the monstrosity that's on my whiteboard right now, and let's look into number 5 here. Before we had the subtraction, now we have the quotient. I'll leave this as it is, I guess, as I erase it. It's gonna take me a minute to erase. I should just spray this whiteboard, right? Be quicker. Get like the worst of it done with the eraser. And then the stubborn ones will spray. Oh, come on. Wait, I keep dropping stuff. Let me spray this thing down. Oh shoot, you know what? Critical thinking, if you are still here, and it's okay if you're not, and you also can't hear me if you're not, so it doesn't matter, but if you are still here, since you're new, I feel like I should tell you about other math streamers that are out there too, in case you need more help in the future. Because I'm not alone in streaming math help. And of course, you don't have to follow anyone else if you don't want to, but if you're looking for more math streamers to kind of expand your pool of people who are available to help you out, there's more out there. I'll link him in a second. Okay. Yeah, if anyone in chat in general is interested in other math streamers, there's a whole list of them there. Okay. So now let's work on part 5. Okay. So we want to consider the limit as x goes to c, f of x over g of x to the k. Okay. So I assume we don't need to bother distinguishing between integer k and rational k. Because last time that didn't end up mattering. Would it matter here in any way that's different? I don't think so. Let's just try doing it for rational, and we'll evaluate at the time. So if we say really, if k is irrational, it seems to follow a similar rule as a square root. So we could lump these together, I guess. For k greater than 0, and k belongs to q, where k equals a over b, and b is even, or k belongs to r minus q. So I'm just going to take irrationals as a... I'm just going to take it at face value that you can't have an irrational root or an irrational power of a negative number. So you can't have the square root of a negative number. The limit as x goes to c exists if I guess I'll say the limit as x goes to c of f of x over the limit as x goes to c of g of x is greater than 0. Or equal to? You can have square root of 0. I assume you can have 0 to the pi. I don't see why not. I guess you're right, Jeff, yeah. Good catch. I mean, in general, we can just say if actually, so I'm going to say that's going to apply to every single case that we look at. Well, no, actually, it won't. Never mind. Because we have to consider negative k's. And for k equals 0, I guess it's pretty easy. So, okay, so we've done it for even denominator rationals and irrationals. We should do it for odd denominator positive rationals, I guess, now. If now we are allowed to have negative numbers, we just need to know that the limit is not 0 on the bottom. I think otherwise we're fine. All right, so let's consider negative k's. I think our rules really just flip. And that's about it. Too. Basically. I think we've covered all our bases for real numbers. For integer powers, have I said anything that's inaccurate? No, we're good. For an integer power, we only care if g of x is 0. Or f of x if it's a negative integer. Okay. Neat little problem. See, there was one answer to this, but maybe we'll have something to add here or something, I don't know. Does h to k have a limit? Oh, true. Yeah. This is a pre-calc student? No way. That's a difficult question for a pre-calc student. Oh my god. Okay. Yeah, I guess so, Peach Tea. Yeah. Actually, I do want to look up irrational exponent rules. Because like I just want to make sure that I'm not missing some kind of rule. Like, why can't you have -2 to the power of root 2? Or is there, you know, maybe some other rule that I'm missing here? Yeah, Jeff, so I've actually never like had to deal with a irrational exponent in a in like a context like this. And it's like I came up with the context of this first one where like if k is rational here, you still need f of x be greater than g of x. Because we're only dealing in the realm of real numbers, I guess. Well, I guess they don't technically say that f of x and g of x have to be real, but I think that's the implication here. Well, g of x doesn't equal 0. It could be that if it's a pre-calc. It's... I wish the wording was a bit better then. I guess maybe in the context of their class, the wording does make sense. E to the pi is -1. You can, or e to the I pi is -1. Probably? I don't know. I don't care that much about why. I care more about what the rule actually is, I guess. But it just seems like they're like a square root, I guess. So I'm just not gonna think about it harder than that now, I guess. A not even number, of a negative number. k is rational with an odd denominator, like a cube root, then the limit always exists. For the second one, positive, then the limit of g of x, or then limit g of x. I need my symbols. Where's not equal to? There it is. It's the first one. Oh wait, no, if k is 0, the limit, if k is positive or 0, I guess? Oh yeah, we're gonna have even more cases here, Jeff. Because now we need to make sure that f of x over g of x is positive for certain cases. That's why this question seems weird for a pre-calc student. 0 to the 0. Oh. Okay. Fair. Neither of them can be 0 then. Okay. That's a good point. Because it was weirding me out that for k equals 0, it would be so simple. Doesn't actually touch 0. Oh, you're right. There's like L'Hopital's. Well, I mean, they're asking for when it does not exist. What can be the exponential value from? Maybe I am making this too complicated. I feel like for the purposes of a pre-calc student, dude, the L'Hopital's on this one is terrible. For number 4, it's not bad. For number 5, you just don't know. Millions of other fish in the sea. No, yeah, I'm away from the second one, but the first one we can definitely do. Yeah, peach tea. Second one is much deeper. The limit of g of x. Do I solve this? Okay, it's not equal to 0 if k is positive, or that limit of f of x is not equal to 0 if k is negative. Than that, but it gets very tricky. I think I'll leave it at this. The TLDR. I think I like that idea. I mean, the second one's already kind of a TLDR for that one. Oh wait, if k is negative, they can't be equal to each other. Oh my god. In some cases, Jeff, yeah, you're right. Since it can involve... I don't know. Shoot, this isn't the entire story for the first one. I may need to walk away. If you have a negative exponent, you need to make sure they're not equal to each other. Ugh. Okay. Uh... Can I say this simply? So I'd love to figure out an explanation for this person, because it's a really difficult question to just drop on a student like this. Yeah, I feel like that too, Jeff. Okay, I'm gonna delete all that, but it seems complex for pre-calculus, or at least not carefully worded enough to exclude weird cases. The short of it for the first one, the simple version is that if k is positive, you just need to be careful of not square rooting or fourth rooting or sixth rooting, etc. A negative number. K is negative. We have the same thing as before. Also, that the limits of f of x and g of x individually can't equal each other. So we don't divide by 0. The simple version of the second one I don't know what that means, Jeff. I'm going to be honest. A primitive nth root of unity. Okay, I've heard the idea of roots of unity before, and you're talking about basically an odd root. -1 to the 1/3 is -1. Just that, okay, so it's okay if you cube a negative number. That's the fancy way. That's the simple way of what you just said, I hope. So if k is positive, make sure the limit of g of x isn't 0, and vice versa. K is negative, that the limit of f of x isn't 0. Okay, I think we'll leave it at this for this person. Question and I'm leaving off some weird cases, like if k equals 0 or is irrational, which are a bit weird. I said weird twice. Isn't the purpose. Weird cases are weird, Peach Tea. Yeah, irrational and positive is fine. Or if k is... I mean, yeah, I'm just gonna leave it at irrational, because I'm not really addressing that part. But yeah, you're right. I mean, irrational is sometimes okay. Because you have to consider... Yeah. Because that k equals 0 thing does apply to the first one too, with f of x minus g of x. I think this is the pre-calc level of thought to put into this question, so I think we'll go with that. I'm exercise left to you for extra credit, basically, Peach Tea. That's probably why Zach was saying that this is like the final exam for real analysis, because this is if you do have 0 to the 0, does L'Hopital's assure you that that exists? I don't think it assures you, just that it can exist. Spherical rectangle question? I'm willing to let you type it in chat and me probably say I have no idea what you're talking about. If that's what you mean by tackle. I'm gonna sign off pretty soon here, but if you want to at least put it in, I can try to tell you something as much as I know. I think Dan's live, so we can raid out to Dan after this. You know, I'm kind of curious. Okay, I don't have any new DMs. Just wondering if that person was still mad and still like posting. Consider a state like Haro, which is essentially a latitude longitude rectangle. Yep. In 3D, are the 4 points coplanar? And regardless, are the vectors between the points perpendicular in 3D? Ooh. So you're considering a spherical rectangle in rectangular coordinates? In which case... Correct, okay. If it perfectly follows latitudes and longitudes, I could see it being coplanar. Like, I feel like it's not a stretch to draw a plane there, because we basically have two kind of like parallel pairs of corners. The angles are certainly not, they won't be 90 degrees in rectangular either. Because you just have a curved surface in 3D. I don't think your angles are going to be 90 either. Like, the shape is still the same. No matter what your coordinate system is, it's just how it's represented. In terms of how I'm interpreting things. Well, if you flatten it out, that's a different story. If you have a literal spherical rectangle that you shoehorn a rectangular coordinate system into, those are like two different things, I guess. Could work an example. Maybe I could. I don't even know if I could. Yeah, I don't even know how to come up. I don't know how to, like, projecting a spherical rectangle into just a normal rectangle. It's going to be a little bit like arbitrary. Like, there's going to be different ways to do it. But if you do project in some way, you can force it so the vectors are perpendicular. Oh yeah, it's going to be something hideous looking if you keep it as is. If you want to warp the shape, well, a spherical rectangle and a regular rectangle just aren't the same thing. You can represent a spherical rectangle in rectangular coordinates, but it's going to be horrible looking, probably. I guess so. The word projection, I guess, is a little bit like loaded. I don't have a deep enough understanding of geometry to be able to tell you if, like, how you if it makes sense to translate a normal rectangle in rectangular coordinates into some kind of equivalent, presumably unique, spherical rectangle. I don't know if that's true or not. Directing a point to the sphere is unique. Oh yeah, I mean yeah, as you say, the origin is fine. Well, so I mean, the original question is that for a state like Colorado, are the points coplanar? So I still don't really get what you mean. If you have a if you have a perfect rectangle, they're of course coplanar, so that's not the interesting question. So you're talking about the spherical rectangle in 3D, which it makes sense to me kind of visually that you could draw some kind of plane between those 4 points, although I haven't actually worked that out. The vectors between points perpendicular in 3D. Yes. It feels like there's some kind of symmetry with being aligned on latitude and longitude, which would make me think that that fourth point would be on it. He draws, a plane that captures that fourth point too. I just, I don't know, Jeff. It's not going to be me, Jeff. I think I'm tapping out. Yeah, I'm gonna rate out. I think because I'm getting tired. Second best beard among yeah. Sorry, Jeff. I've been going for 5 hours and 20 minutes, and even if I hadn't, I don't know if I'd want to do the math anyway. I'm gonna be honest. Sorry. It's just a lot of work. See, I'm gonna cut the YouTube stream off here. So if you're on YouTube, I appreciate you, and I'll see you around.